It's going to be a problem like this. This problem is different from the previous types of problems that we've been doing. How? Yeah, it's no zero. Yes, we're going to fill in the blank just a second. There's no zero at the end. So for a problem with no zero at the end, on number 3 you have the blanks here, there are a couple steps. We need to get it equal to 0. We have to get a 0 on the end so that we can do what we've been doing. So the first step to do is either add or subtract things from both sides. So we're going to be like adding the 4 or subtracting 3x or doing something like that from both sides of the equation first. That way we can get a 0 on one side. We want to then combine any like terms that we have, and we want to make sure that it is in order. Now the order that I am talking about is all of these things always go in this order. Something x squared plus something x plus something. We want it to be in an order based off of the powers of x, the x squared thing or the a squared thing, and then the just the letter thing by itself, and then the constant, the number at the end. If there was an x cubed, it would be solved in a different way. It wouldn't be solved in the same, it could be solved in the same way depending on the way it was set up, but it's not always going to be solved this way if it's an x cubed. We will deal with x cubes when the time comes. So right now we're still dealing with quadratic equations, a x squared or an n squared in this case. I want to get this thing set equal to 0. So what number do I have to get rid of to do that? The 4. I got to get rid of the 4. How do I get rid of the 4? Add 4. So we're going to add 4 to both sides of the equation. That will get rid of everything that is on the right, leaving you what number over here on the right? 0. Equals. And then this stuff stays the same, n squared minus n minus 42. Very good. All right, so this is my new equation. Now, everything from this point on is exactly like what we just did. The first step, though, is to get it equal to 0. If you forget to do that, very likely the problem will not actually factor out. And even if it does factor, you wouldn't be able to solve it. It's just much uglier. You have to get it equal to 0 first. So now let us go ahead and factor this. What numbers multiply to the 1 n squared? 1 and 1, of course. Those are both n's. I need several factors that would multiply to 42. But being that this is a 1 in the middle, those numbers are probably going to be pretty close to each other. So what numbers would multiply to 42 that are very close to each other?
8 and 7.
Does 8 and 7 make 42 when you multiply? What?
7
7
and 6.
and 6. Very good. 7 times 6 is 42. But that would multiply to a positive 42 when we want a negative. Which one do you want to be negative, 7 or 6? 7. Why would you choose the 7 to be negative? Cross multiplying, 1 times negative 7 is negative 7, 1 times positive 6 is positive 6, and what do those add to?
Because if you do negative 6, it makes it positive.
Right, if you had a negative 6 instead of a negative 7, this would have been a positive 1, and we need it to be a negative 1. So again, this is trying to guess numbers that will do these, and it becomes easier as you do more of them. What is the factored version of this?
N minus 7, n plus 6.
N plus 6 is equal to 0. From here, what we need to do is we need to set up two equations. We need to solve the two equations, try to get n by themselves. So somebody tell me what the first equation is. N minus 7 equals 0. Second equation. Very good. N plus 6 equals 0. This will give me two answers. How do I solve the first equation? Add 7, giving me n is equal to 7. The second equation, when I subtract 6, n is equal to negative 6. And those would be my two solutions.
Yes.
Does anybody have any questions about that? Holding the thought. It's really hard to hold a thought in your head.
Hold a thought?
Yeah, hold a thought.
Okay.
Very intriguing.
Because you're thinking about something else by trying to hold it.
Indeed. You ever tried not to think of something? You inevitably have to think of it if you're not trying not to think of it. All right, so Michael, you got that?
The game.
Almost.
You lost the game.
Got it.
Alrighty. Let's go to a more difficult one. One that doesn't just have a number over there, but sometimes, every once in a while, you'll find something like number 12. Number 12 doesn't just have a number on one side, but it has letters and it has also other numbers. It is multiple steps that it's going to have to take to get rid of it. We need to get everything onto the same side of the equation. So the 16 and the 10 both have to go away to make a 0 over there. How do I get rid of the 10? Yeah, we'll add the 10m. How do I get rid of the 16? Well, do you want me to write this step out first? Let's go ahead and write it out. This is now m squared. Can I add 10m to m to get like 11m squared? No, I just have to put it down there. I cannot combine it. It's an unlike term. And equals, what's over on that side still?
You gotta add the 16.
Yeah, okay, so you're trying to do 2 steps at once, which is fine. Go ahead and do that. I am just going to write out the steps so everybody sees what's happening. How do I get rid of the 16? Add the 16 to both sides. And can I add the 16 to the 10 or the m squared? No, I can't. So m squared will get brought down.
I thought that the only way to get rid of the number from a variable was by dividing.
Yes, that is the only way to get a number in front of the variable, but I'm not getting rid of the number. I'm getting rid of the whole thing. I am adding 10m to cancel out all of the 10m. All right, so this is the equation that I have there. Be aware, I did not add the 16 to any of the 2 numbers because there are no other numbers. Right? There's not like a 3 by itself on the left-hand side or anything to combine the 16 with. It is just 16 getting moved over to the other side of the equation. Also be aware that it needs to be in order. M squared, m, no m's. So we have to go in order based off that if we expect the factoring thing to work. Are there any questions about how I got it to this black equation right here? Yeah. All right, good. So let's go ahead and use the process that we've been doing this whole time. What multiplies to m squared?
Oh,
1 and 1. Of course, they need the m's on them. Okay? We now need to figure out about the 16.
8 and 2, 4 and 4, or 1 and 16.
All right, 8, 2, 4, 4, 1, 16. What combination of numbers do you want to use? 8 and 2 would be the logical one because 8 and 2 would also do what? 8 plus 2 is equal to 10. So yes, that works out just fine. What is the factored version?
M plus 2.
Very good. M plus 8, m plus 2 is equal to 0. So what are my 2 equations going to be?
Yeah.
M plus 8 equals 0, and
M plus 2 equals
so this will give me 2
0.
solutions.
M equals negative and M equals negative.
All right, this is a very easy equation. M is equal to -2. Are there any troubles with any of those?
Not really.
Okay. So the most difficult part about that, besides the factoring, would probably be getting this in the right format, making sure that we are trying to put these things on the same side of the equal sign as the m squared by doing the adding and subtracting steps to get rid of them.
What about number 22 or number 27?
All right. Does everybody have this one done? All right, so 22 and what was the other one you asked about?
27.
Okay. So this is a good one. Number 22 is a very good one because it has a lot of stuff on it. I want to get everything over on the same side, which means I'm going to have to get rid of something. What am I going to get rid of on the right there?
Both of them. So
Yeah. How do I get rid of the negative 8p?
plus 8p plus 8p.
All right, so I'm going to add the 8p to the other p's, right? The p's are right here, so I'm going to add 8p to this stuff. And I'm going to go ahead and do the other step as well. If this loses any of you, just let me know and I can redo it. So I'm going to also add the 8p squared to both sides. I'm going to add it to the left side as well. The reason why I'm doing both of them is because I add 8p and that'll cancel that one out. I add 8p squared and that'll cancel that one out. And what is left on the right side of the equation? A 0, right? Because everything canceled out over there. If I added it to the right side to cancel it out, though, I have to also add it to the left side. And when I do that, that's going to change these numbers, the ones that are like terms with it. -7 plus 8 is 1p squared. Negative 13 plus 8 is? Negative 5p minus 14. From here, everything is the same. I'm not going to work this one out entirely. You guys can do that. I just needed to show you how to get it into the stuff that we did yesterday. So this is the one where you'll break down the 1, you'll break down the 14, and do the numbers that add to 5. All right? Are there any questions about how this was set up in the right format? This problem is not done. Don't stop here just because I am. Finish the problem. I will look at, you also said Jackson number 27, is that right? Okay, number 27 is very similar to that one. There's only one thing to get rid of, though. We have to get rid of the 8x squared by adding it to the other side. So to get this set up in the right format, you would add 8x squared to both of the x squared terms. Those would cancel out, leaving you 0. Negative 2 plus 8 is 6x squared minus x minus 35. And now it is in standard form, and we can factor it and set them equal to 0 and all that kind of stuff. Does that make sense? Jackson?
Yes.
Okay, good. There is one other problem that I want to do with you. This one is also not done. You do need to finish it. I want to do this other one out entirely.
Wasn't number 27 yet.
I didn't really do anything on 27.
We just did.
I didn't really do anything on 27. I did a little tiny bit, that's it. Where'd the problem go? There was a good problem that had a unique situation. This one right here, number 8. Go all the way back to number 8. Everybody back on number 8, because 8 has a unique thing that happens to it. This happens every once in a while. It's not a big deal when it happens, but it does make people freak out for some reason. All right, it's not really all that hard. What do you need to get rid of? The negative 5. How would I get rid of the negative 5? Add 5. Add 5. You should notice something. This is going to be 7k squared plus 4k equals 0. What happened to the... It also canceled. Well, that is interesting. What am I going to do now? Have I got any idea? All right, well, what number is really there? 0. Yeah, 0 is really there. There is a 0 there, is there not? Right? There are still the 3 numbers there. One is just a 0. Okay, let's try it. Let's just do it the same way. We're going to pretend that it's a normal, plain and simple problem, and we're going to just do it. What numbers multiply to 7? 1 and 7, right? What numbers multiply to 0? Anything in 0. I can put any number I want. I could put 1,000 and 0 there if I wanted to. But will 1,000 and 0 work? 7,000 and 0, will that add to 4? What number do you think I should probably use? 3? All right, so 0 and 3, like that. 3 plus 0. Okay, why don't we say 0 and 4? You can use literally any numbers because anything times 0 is 0. So I can use any numbers. Would it be beneficial for me to put the 4 at the top? Would that help? What would happen if I put the 4 on the top? 4 times 7 would be 28, way off of the 4 that I need. Putting 0 on top gets me canceling out the 7 completely. 1 times 4 is 4. Makes this problem a little bit easier. Does that make sense what I did there?
Yeah.
So the factoring of this will end up with 1k plus 0 and is equal to 0. Does that make sense?
Yeah.
Everybody good with that? Okay, same process, even though it's kind of weird with the 1k plus 0 thing. 1k plus 0 equals 0. 7k plus 4 equals 0. Solve the one that's not weird. How do I solve that one over there on the right? Subtract 4. 7k is equal to negative 4. Divide by 7. And k is negative 4/7. That's one answer. But what about this other answer? This is a weird equation.
It's just k equals
Yeah,
0.
just k equals 0. Really, plussing 0 to something doesn't really even matter, right? Adding 0 won't change it. 1k equals 0? Well, simply k equals 0 then. Any questions about that? Alright, the majority of this worksheet is exactly like what we did the other day, with the only additional step being this blue stuff up at the top where you have to get it equal to 0. So go ahead and start on that. If you have trouble getting it equal to 0, please let me know, and I will help you get it equal to 0.